Let's start off with this integral by rearranging it. So you are going to have I to be equal to the integral from 0 to the cosine inverse of 1 over 4. The secant of x is 1 over the cosine of x, right? And tangent of x is the sine of x over the cosine of x. This is multiplied by the ln of 1 plus the square root of the cosine of x and then dx. Cool. Now we can multiply the terms in the denominator. So the upper limit is the cosine inverse of 1 over 4. We are going to have the ln of 1 plus the square root of cosine of x, right? I'm going to bring the sine of x here and then dx. This is divided by cosine of x times itself is the cosine square of x. And now at this point we can do a substitution. We are going to let u to be equal to the square root, we are going to let that to be equal to the cosine of x. Alright, so du here is going to be negative sine of x dx, right? So that implies that negative du is going to be equal to the sine of x dx, right? So I'll just replace this one with negative du, changing limits. When x is equal to 0, the lower limit, we have u to be equal to the cosine of 0. Cosine of 0 is 1. And when x is equal to the cosine inverse of 1 over 4, that is the upper limit, u is going to be equal to the cosine of the cosine inverse of 1 over 4. And that is 1 over 4. Alright, so now the integral in the u world will look like this. You have I to be equal to the integral from the limits will now range from 1 to 1 over 4, right, of the ln of 1 plus the square root of u, right? All this one divided by u squared multiplied by sine of x dx is the same as negative du. And this is equal to this negative. I'm going to switch the limits and that is going to nullify the negative. The integral is now going to range from 1 over 4 to 1 of the ln of 1 plus the square root of u. All this one divided by u squared du. Alright, so now let's do another substitution. Why not? I'm going to let's say v to be equal to the square root of u, right? So that means that when I do this, u squared is going to be equal to, u is going to be equal to v squared, right? That is squaring both sides. And then du is going to be 2v dv. So I'm going to replace it with 2v dv. And then the change in limit, right? So when u is equals to 1 over 4, we have v to be equal to the square root of 1 over 4. And that is equals to power series 1 over 2. And when u is equals to the upper limit 1, v is going to be the square root of 1. And that is equals to 1. How do I find an expression for this one in terms of v? Right? We know that from here, u is equal to v squared. So that means that u squared here is equals to v raised to the power 4. And now the integral in the v world will look like this. Now you have the integral from 1/2 to 1. Those are the limits of integration for v of the ln of 1 plus v all over u raised to the power 2 is the same as v raised to the power 4 times du is 2v dv. Alright, so this is equals to 2 is a constant. It comes in front. The integral from 1/2 to 1 of the ln of 1 plus v. All this one is divided by v is going to cancel one of the v's at the bottom, leaving v to the power 3 and then dv. Alright, so here I'm now at the point of doing integration by parts. So we have 1/2 to 1 of the ln of 1 plus v. This is divided by v to the power 3 dv. Cool. Now let's do integration by parts. D for differentiation, I for integration. So I am going to differentiate the ln of 1 plus v because we can integrate that. So that is going to be what we will differentiate, and we are going to integrate 1 over v to the power 3. This is plus, next one is minus. Differentiating this is 1 over 1 plus v. And integrating 1 over v to the power 3 is negative 1 all over 2v squared. Alright, so remember when we multiply diagonal terms, there is no integral, but when we multiply terms horizontally, we have to take the integral. This is trivial now. So we have I to be equal to 2 times integration by parts. So diagonal terms, that is going to be negative the ln of 1 plus v. All this one is divided by 2v squared. And then negative, when you multiply terms horizontally, that is going to be positive. Then the integral, 1/2 is a constant, it comes in front here. And then we are going to have 1 all over v squared multiplied by 1 plus v, and then dv. The limits of integration from 1/2 to 1. This way you are done with the integration. Take the limits of integration from 1/2 to 1. All this is multiplied by 2 in front. We have I to be equal to, now this 2 is going to cancel this 2, right? So what you are left is negative ln of 1 plus v divided by v squared. This from 1/2 to 1. Next, this 2 is going to cancel this 2, and then we are going to be left with plus the integral from 1/2 to 1 of, permit me to, I'm going to add 1 to the numerator, v to the numerator and subtract v. When I do this, then I'll divide by the denominator, which is v squared multiplied by 1 plus v dv. Alright, cool stuff, right? So we have I to be equal to, now let's plug in the limits. The upper limit first, negative ln of, plugging in 1 in place of v, that is going to be 1 plus 1, which is 2 divided by 1 squared. This is the upper limit minus the lower limit. The lower limit is going to be negative ln of 1 plus half, that is going to be 3 over 2 divided by half squared, like this. Alright, and then plus this one, I'm now going to split this one into 2 different integrals. The integral from 1/2 to 1 of 1 plus v divided by 1 plus v times v squared dv. The next one is going to be negative the integral 1/2 to 1 of v all over v squared times 1 plus v dv. Let's simplify the limit, shall we? This one is, we have negative ln of 2 like this, and this is going to be positive because negative, right? So positive, you have the ln of 3 over 2. All this one is divided by 1 over 4, which is 4, right? So this is 1 over 4. So 1 over 1 over 4 is 4, which is what we have here. Alright, and then plus the integral from 1/2 to 1. This one is going to cancel this one out nicely, and you are left with 1 over v squared dv. Minus, we have the integral. So this one is going to cancel 1 here. So permit me to just do it like this. So I'm going to cancel this v and then this. So when I do that now, that is going to be left with 1 here. Right. So that is now 1 all over v multiplied by 1 plus v. And now what I can do here is to add 1 and subtract 1 again. So I have 1 plus v minus v. All this one is divided by v multiplied by 1 plus v dv. Alright, so I have I to be equal to negative ln of 2. So I'm going to write it like this: 4 times the ln of 3 over 2 minus the ln of 2, right? Plus, integrating this one is negative 1 over v, the limits of integration from 1/2 to 1. And this one, splitting this one into 2 different integrals again, I have negative the integral of 1 plus v all over v times 1 plus v dv from 1/2 to 1. The next one is going to be negative, right? That is going to be positive the integral from 1/2 to 1 of v all over v times 1 plus v dv. Alright, so I is going to be equal to 4 times the ln of 3 over 2 minus the ln of 2. And this one, plugging in the limits, you have negative. Plugging in the limits, you have 1 over 1, which is 1 minus 1 over half. 1 over half is 2. This is what we have. minus this one is going to cancel this one out nicely, and what you are left with is the integral from 1/2 to 1 of 1 over v dv. And then this one is also going to cancel this one, and you are left with the integral from 1/2 to 1 of 1 all over 1 plus v dv. Alright, so I is going to be equal to, here we have 4 ln of 3 over 2 minus the ln of 2, and this one is positive 1, that is this one, and then minus, we have integrating this is the ln of v from 1/2 to 1, and integrating the last one is the ln of 1 plus v from 1/2 to 1. What you are left now is arithmetic, so the calculus is done. So minus the ln of 2 plus 1, and then plugging in the limit, that is going to be ln of 1 is 0 minus the ln of 1/2, like this, plus this one, the upper limit is going to be the ln of 2 minus the ln of 1 plus 1/2 is 3 over 2. A lot of arithmetic, right? So this is 4 times the ln of 3 over 2 minus the ln of 2 plus 1. This one is going to be negative is going to cancel out, and I'm going to have plus the ln of 1/2, and then here you have plus ln of 2 minus the ln of 3 over 2, like this. Alright, so there will be cancellations, right? So I is going to be equal to, so 4 times the ln of 3 over 2, and then the ln of 3 over 2, we subtract that, that is going to be 3 times the ln of 3 over 2, right? And this one, we have negative ln of 2 is going to cancel the positive counterpart, right? So this and this will cancel out, and you are left with plus the ln of 1 over 2 plus 1. Alright, so let's simplify this one to match with the answer that Wolfram alpha is given. So we have 3. This one, using the laws of logarithm, is going to be the ln of 3 minus the ln of 2, right? That is the first one. And ln of 1/2 is negative ln of 2 from the laws of logarithm plus 1. So what we have now is going to be equal to, this is 3 ln of 3 minus 3 ln of 2 minus the ln of 2 plus 1. Alright, so when you combine this, what do you get? You have 3 ln of 3 minus 4 times the ln of 2 plus 1. And this one, using the power rule of logarithm, this is the ln of 3 to the power 3 minus the ln of 2 raised to the power 4 plus 1. And 3 raised to the power 3 is 27, so this is the ln of 27 minus the ln of 2 raised to the power 4 is 16 plus 1. So the answer that Wolfram alpha is given is 1 plus, using the laws of logarithm again, this is the ln of 27 over 16, right? So this one is the answer that Wolfram alpha is given for this integral. So that is the value for this integral. So this integral is very easy. If you realize that you have to do 2 substitutions before doing integration by parts, right? So this one evaluates to 1 plus the ln of 27 over 16, right? So if you find this video helpful, please give me a thumbs up and subscribe to my channel for more engaging content on integrals. I thank you so much for watching this video, and I'll see you in the next one. Bye bye.